I am ready and I'm super happy to get started. Thank you very much. Thank you very much for having me here at the Serverless Architecture Conference. It is a pleasure to speak here about a topic that is very near to my heart, and that is the combination of Rust plus Wasm WebAssembly, which is, in my opinion, a real dream team for serverless applications. In the next 45 minutes, I'm going to give you a quick introduction why I think this is a really nice combination. And as promised, I show you lots of demos of using Rust and WebAssembly in edge cloud environments. I will choose two very different environments to show you two very different approaches of reaching the same goal. So let's get started with a quick intro, and then we will jump right into the code, and you will see a lot of code, you will see a lot of demos, and hopefully we will have a lot of fun together. If you have any questions, you can ask the questions. If you are in the room in London, you can always ask the questions live using the microphones, or you can also use the live chat if you are connected to the website of the conference. Just use the live chat. I have the live chat here on my side on a separate monitor, and I can always see your questions, and I will answer them as soon as possible. So let's quickly talk about what the core problem is. You know, I have been a software developer for many years, and my core expertise is building distributed systems. And if I think back how I build medium-sized cloud apps today, in many situations I have a database or some kind of relational or NoSQL database. I have a bunch of web servers or container runtime environments on top of it. I have maybe some front-end, back-end for front-end, things like that, serverless apps and so on. Then I have some networking components going on. I have a lot of infrastructure in the back end with having to manage networks, virtual networks, DNS environments, and things like that. All in all, that's just a really big and complex thing. If you ask me, there is nothing wrong with this kind of working, but at the end of the day, the expectations of our customers and users are constantly rising. Also, complexity is constantly rising. We have to get ready to tackle that. And what we need to do is we need to reduce complexity and bring also the software near to our customers so we can fulfill questions like be more productive, reduce costs, enhance performance, and so on. So what we essentially would need to do with traditional cloud apps, we would need to spin up all these complex technology stacks distributed around the globe, and that is somewhat complicated. And what I would like to talk today about is a simplified approach. I would like to talk about the cloud edge, about serverless applications on the cloud edge, and using Rust as a very good language choice for achieving exactly that. We need new tools, and we want to build more with less. That is my point. And here comes in serverless. What we essentially want to do is we want to build serverless everything. We want to do near user deployment. We want to buy more and build less ourselves, and we want to reduce complexity. And this is exactly what we are going to talk about. Now, this is what I call an edge cloud. There are many different definitions of what the edge cloud is, but this is a screenshot of a company called Cloudflare, which you are probably familiar with, and all their data center locations distributed across the globe. I personally do a lot of work with Azure, Microsoft Azure. They also have a lot of data centers, but by far not this number of locations. So when I talk about using the edge cloud, I'm talking about systems like that. I would like to take my Rust code, compile it to WebAssembly, and let it run in a serverless fashion in data centers around the globe, in dozens, if not hundreds of data centers, so it runs near to the customer, and therefore everybody has great performance. Now, in the case of Cloudflare, which you will see in a few minutes, you have multiple services, and here I just have named a few of them, and we will focus in our demo here on Cloudflare Workers. Now, Cloudflare Workers is a possibility to run APIs in a near customer fashion on the cloud edge, and you have additional features surrounding this offering. Of course, there are other edge cloud providers, and here I just name a few of them. And besides Cloudflare, I will also demonstrate Spin from Fermyon, which is also a serverless provider, also with great support for WebAssembly and of course Rust, but with a completely different solution approach. Okay, these are the two edge cloud providers that you are going to see. And with that, without any further ado, I would like to jump right into the demos, right into the code, and I will get back to these slides in a few minutes. The first thing that I would like to show you is a very simple sample using Rust and WebAssembly so you understand how the general approach works. I don't assume that everybody in the room and at home has in-depth knowledge about Rust and WebAssembly, so I will describe it a little bit, but please understand that I cannot do a complete training, a complete Rust or WebAssembly training. I only have 45 minutes, and the core of my talk is really serverless and cloud edge cloud environments. But still, we need to have a little bit of understanding how this works in Rust. Now, what you see here is an intro sample that I typically use in larger workshops and trainings and so on. But still, it is a very good thing to demonstrate the fundamentals. What you see here in my project is essentially a library. You see it here. It's a Rust library, and the library itself is nothing special. It's just a bunch of Rust code doing very, very simple hello world things. We will switch to a more elaborate example in a few minutes then. As you can see, if you have written Rust code before, you have the usual cargo toml file, which is the configuration file of the cargo application. If you are not familiar with Rust, cargo toml is like a package JSON in JavaScript or TypeScript, for instance, or the CS proj file in a C# application. Now let's take a look at this example. This example, lib.rs, contains a bunch of methods, and you see if I run it in the browser, I can, for instance, access the alert function of the window to display something in the browser. If I'm not in the browser, I can do some calculations. You see, I can work with different data types, like for instance, floating point values and optional floating point values, integer values, things like that. If I scroll down a little more, you see that I can write things to the console by doing a console log and things like that. So essentially what I do here is I write simple Rust code, and I can interact with the host, which is hosting my, my Rust code, my WebAssembly code. But the important thing here is that I'm assuming here that the host of my Rust code is a JavaScript runtime environment. So what we see here is Rust code, which will be compiled to WebAssembly, which is specifically targeted to run in a JavaScript environment. And that is exactly what providers like, for instance, Cloudflare do. Because they are using, and now let me go back to my slides for a second, they are using a technology which is called V8 isolates. V8 isolates is the base technology for many cloud providers like Cloudflare, Vercel, Netlify, and so on. And essentially what V8 isolates are, they are the technology which separates your tabs of your browsers from each other, so that you can make sure that not one tab is influencing the other in a negative way. So this technology is very well tested because it was battle tested in browsers. There are no virtual machines here. We don't have container technology or something like this. This is pure V8, a JavaScript runtime environment, and we can run everything that runs in V8. So that means I can run JavaScript-based workloads, and more relevant to this talk today, I can run WebAssembly workload. But as I said, this is not running on VMs, this is not running in containers, this is really running in a JavaScript environment. And therefore, it makes sense that I can communicate with the host, with the JavaScript host. And in order to make that simpler, there is a really important library or technology, I would say, which is called Wasm BindGen. It's the WebAssembly binding generator. What this thing does is it's bridging the gap between Rust on the one hand side and JavaScript technology on the other side. For instance, strings. If I have a JavaScript string, if I have a string in a JavaScript environment and I would like to call a Rust method, I have to somehow encode this string into the UTF-8 format. Who does that? Who is responsible for that? The answer is Wasm bindgen will generate the required code to do exactly that. So from the viewpoint of a JavaScript or TypeScript developer, I can simply pass a string into the method which is implemented by Rust. From the viewpoint of the Rust developer, I can simply consume a str or a string and magically everything works. Something has to go on in the middle. And this is exactly where this technology Wasm bindgen comes into play. Wasm bindgen comes together with a tool which is called Wasm pack, which compiles the whole Rust code and generates a package. Let me show you how that works. I now take all my sample code here, and so far you do not need to understand the details, what's going on here. Just the big picture is important now. Let's run exactly this Wasm pack statement here. Just build. Run it. It's running it, it's optimizing it, and at the end of the day, here I have a folder which is called pkg package, and guess what? Inside of this folder, I have my Rust code compiled to WebAssembly, but not just the WebAssembly code. What I also get is a bunch of helper JavaScript and a bunch of helper TypeScript. And this is exactly where Wasm pack and Wasm bindgen place the helper code necessary to bridge the gap between JavaScript and Rust. So whenever I want to use Rust using WebAssembly in the context of a V8 runtime environment, I go through Wasm pack or Wasm bindgen, which will generate not just the WebAssembly, but also the JavaScript code required to do the marshalling of the data types and things like that. Now, if I would like to use this in a JavaScript website, this is not the core topic of this talk, but still I would like to show it to you. It's really not complicated. All I need to do is I need to reference the package which was created by Wasm bindgen and Wasm pack, and that's it. That's all I need to do. So if I take a look at the TypeScript code, which makes up this very nice little application here, I can, for instance, here say write to console. And this write to console, if I take a look at the implementation, is something that comes from the generated TypeScript code, which lives inside of this package folder. I didn't write that by hand. What I did is I implemented exactly that Rust method, as you can see, and this JavaScript code and respectively the TypeScript type definition around it. This is responsible for bridging the gap between the languages, as I told you. So using this Rust code in JavaScript and TypeScript is really a piece of cake because you have this tool which generates the required language bindings. Now today we don't want to take a look at websites. We really want to take a look at serverless functionality, which runs in the browser. And therefore, I close up the www folder here, and I want to show you the second file, which you see here, which is again Wasm pack, but this time I'm not building something for target browser, but I'm building something for target Node.js. This will again compile everything to WebAssembly, generate JavaScript code, but this time it's generating JavaScript code and WebAssembly code specifically for the use in the server. We are in serverless mode, right? I mean, true serverless would mean running everything on the client, right? That's the best serverless you can have. But here we are talking about serverless, meaning we don't care about the servers. Still, we run our code on servers, but somebody else is responsible for it. So let's run it for a Node.js environment. So just build Node. Let's do it that way. Compiles everything, and this time it's putting everything into a folder which says package Node. It looks very similar to what you have seen before, but as I said, there are tiny little differences between the browser-oriented WebAssembly and JavaScript and the Node.js-oriented JavaScript and WebAssembly. Now, how can I run that in a Node.js environment? Really nothing magic here. What I did here, again, I built a Node.js application that wants to call into Rust. And again, I define a dependency as you see it here, but this time I'm referencing package-node. This folder is what I reference. And inside of my Node.js app, it's really trivial to consume my Rust code. I simply say, hey, import Wasm examples, and then I call write to console, which will do exactly what you have seen before. It takes this string and calls back into JavaScript land using console.log. So if everything works nicely, we should see hello world on the console, even if I run it in Node.js and not in the browser. So let's try that. I'm already here in the node folder, as you see. So I'm going to say npx tsnode app.ts, and let's see, crossing fingers, and it worked like a charm. This is just the output of the initialization function. I will not go into details here because that is very much wasn't bindgen related and not related to this talk today, but this is the important thing. So where I would like to draw your attention to is that because Cloud Edge providers, which are perfect for serverless applications, because many of them rely on V8 and the V8 isolate technology, we can run JavaScript-based workloads on them. And because Rust and WebAssembly works so nicely with JavaScript environments, it should be a big problem to take our Rust code, compile it to WebAssembly, and with the use of Wasm bindgen and Wasm pack, take the resulting code and run it in a serverless Cloud Edge provider. That's the idea. We will see later on that using V8 and V8 isolates is not the only approach to doing serverless. On the contrary, there is a more WebAssembly native approach too, and I will definitely show you that once we leave JavaScript land and take a look at Spin, at the Spin framework as an example for a native WebAssembly serverless environment. But for now, we will stay in JavaScript V8 based serverless cloud environments, and then we'll make the switch. In order to explore what we can do really in something like Cloudflare, for instance, I'm going to close up this sample, because this sample was really just to show you the basics of Wasm pack, Wasm bindgen, how the code generation works, why we have a little bit of JavaScript and a little bit of WebAssembly. So let's get rid of this sample and go into the second sample of my talk today. I created a tiny little sample, and you know what? Let me show you how our sample works. I've built a small little front end for my sample too. Oops, this is not what I wanted to do. I wanted to do that one. I know that this is not a front-end conference, but still you should see what I would like to do. My small little front end here shows you, I called it alphabetic confetti. It's just a word finding puzzle. You see, on the right-hand side, you have some words, and inside of this word puzzle, these words are somewhere hidden. Hey, help me, can you find something? Let me see if I find anything. Here, for instance, I see that we have the word school, you see, or here we have the word computing, and yeah, I guess there are more words here. I think you got the point. And in our fictitious requirements here, we want to build this application, but we want to have a web service, a serverless web service, where we can pass in a bunch of these words, and it will auto-generate an alphabetic confetti quiz looking somewhat like that on the left-hand side. And we want to have it completely serverless. We want to take this and run it across the globe in Cloudflare data centers and in Fermion Spin data centers. This is our scenario. And by the way, if you would like to try it, you feel free to try it. You can try it on your own. It's exactly here. So if you want to take out your phone, or if you are fast enough in typing, this is public, so you can try it immediately. I hope you will not break my serverless infrastructure that I will use in the next few moments. Okay, so this is in the wild. It really works. Okay, so this is the scenario. First, of course, we need the generator. And what I did in preparation for this talk is I have written a naive puzzle generator. Please don't be angry with me. This is not the world's most complicated word puzzle generator. It's really rather naive. What it essentially does here in Rust, it's implemented in a library. It offers a single public function that receives generator options. The generator options consist of the size, the square size that should be generated, and a list of words that you see here. So I pass in the words and the size of the square. And what this thing essentially does, it's using a brute force approach by trying to place these words randomly, horizontally, diagonally, and vertically. And hopefully 100 iterations are enough to be able to place all words inside of the puzzle. If not, some words are simply dropped. So it's not an elaborate puzzle generating algorithm. That's not the point. The point is I can build more than just hello world. You see, I will scroll through it. It's all open source in GitHub. You can take a look at the code and check whether I did something meaningful. At the end of the day, it's decent business logic that's doing a little bit of computation. This has nothing to do with any kind of web API or browser technology. It's not limited to Wasm pack or Wasm bindgen. It's just Rust code, nothing more. It's pure Rust library. That's it. Now I would like to take this one and make it available in a serverless API in the Edge cloud. What do I do? Let's first take a look at the Cloudflare approach. Here you have the word puzzle Cloudflare. Let's take a look at this library. Again, it's a library, as you can see here, but this time the library really depends on Cloudflare Workers. I chose Cloudflare because it's a very popular option for Edge Cloud, and the worker framework is used heavily in many different industries. I have a lot of customers who I work with where we use Cloudflare and Cloudflare related services. This worker framework shows us that this library is now depending on Cloudflare. So this can just run in Cloudflare. But the important thing is that my dependency here is showing you that I can reuse existing logic code. And that's a very important argument for using Rust in such serverless environments. Because you might already use Rust for implementing high-performance, high-secure business logic. Maybe you have some calculation logic, some data validation frameworks, some machine learning stuff where Rust is also pretty great. Or maybe you generate some visualizations. You have existing logic and you would like to run this logic in the Edge cloud. And this is exactly where the combination of Rust and WebAssembly comes along. You take your Rust code, you do not need to rewrite it in a different language. You take your Rust code and you simply compile it to WebAssembly. This is what we do here. We combine the vendor-specific worker framework with the logic that already exists that you have seen a few moments ago. There are additional things going on, like things like that, but I only have 45 minutes. Please take a look at the code yourself. I'm pretty sure you can use this as a kind of basis for further research. Maybe you do some Google research or you ask ChatGPT for help. I'm pretty sure you will find out what this code does. Now let's take a look, let's dive a little bit deeper into the code itself. Let's take a look at lib.rs. Now the lib.rs is the implementation of the API, and it's really short. You see, that's all. It's just 37 lines of code, that's all. What we see here is we have a main method, and this main method is always called when the worker framework of Cloudflare receives a request. So every request goes through this main method. We get the request, we get some information about the runtime environment, which we can use to get some information, and we have a so-called worker context, which we don't need in this example. What we need to generate is a response, an HTTP response. Now, the Cloudflare worker framework the worker framework of Cloudflare, this is what I wanted to say, comes with a router. As you can see, I can specify a router, and I can here register as many routes as I want. In this case, I have a, let's say, hello world route, which answers on the root folder, and I have a post route on the generate thing. And this generate thing is implemented down here. This is the Cloudflare specific API handler function. What does it do? First, it deserializes JSON into the generator options that you have seen before, so the size and the word list. Now, I have just defined that the size must not be greater than 20. If it is greater than 20, we return a bad request. I think you can guess from the context how you could build more elaborate error handling, returning different error messages, error codes, error responses based on your concrete environment. Last but not least, I'm calling into the business logic, and this is where the magic happens. This is where the puzzle is generated. And last but not least, I'm converting this resulting puzzle into JSON and add a little bit of course. So I want to call it from my UI. The UI is a single page app, and therefore I need to be ready for course. And okay, granted, I'm not very secure, I know it, but for the sake of the sample, it should be okay. So now we have an environment that is 100% Rust, and now I would like to run it and make my worker available. But first I need to, of course, try it locally. And for that, I can use a tool which is called, I want to do Wrangler. See? This is the tool that I'm going to use. Wrangler comes from Cloudflare, and this Wrangler tool is essentially an NPM package. This NPM package is responsible for building my Rust code. So behind the scenes, it's going to produce something similar to what you have seen before. You see? It essentially generates also some JavaScript code and TypeScript code, and at the end of the day, I will end up with WebAssembly. But when I use a provider-specific framework like the worker framework from Cloudflare, I get a tool with which I can do the compilation and also the testing. This is important. So I'm not using Wasm bindgen and Wasm pack and so on directly, but I take the build tool which comes from the Edge Cloud provider. This is what I do here. And for that, we are going to try it, of course. And I made a just file here, cfdev, that should now run my API locally. You see, everything is compiled, the Wasm code is optimized, and now I will end up with a Wasm file and the necessary JavaScript file. That's magic for me. I don't need to understand the details that are going on. All I have is a URL, and if the demo gods are smiling, I should be able to call this API. So currently we are here. Let's take that one. Let's see if it answers. Oh yes, hello from workers, that looks good, and now generate a puzzle, and here you see the puzzle with all the words in it. Works perfectly fine running on my computer currently on localhost. Now if I'm happy with that, if I say, okay, that looks good, of course I would like to deploy this stuff. What do I have to do to deploy this stuff? All I have to do is I have to run deploy. Let's take a look behind the curtain. It just says Wrangler publish. Wrangler publish will take the settings in my Wrangler toml file. Here is the name. It will check whether in my Cloudflare environment there is a worker which is called word puzzle, and then it will simply take all the necessary Wasm code and JavaScript code and upload it to Cloudflare. And it's a single line of code. All I need to do is I need to say Wrangler publish. That's all. So let's try that. Just cf, like Cloudflare, deploy. Let's do that. Run it, and you see everything is compiling. It's optimizing, and that is important because the size of the WebAssembly matters when it comes to Cloudflare. It should be done in a second, and here we are. Our application has a size of 203 kilobytes. This is now uploaded to Cloudflare, and now we should have everything running all across the globe. This is now already distributed across the globe in the entire Cloudflare network. My Rust code, my WebAssembly code should be running there. Let's give it a try. Let's give it a try by running it now, not on localhost, but this time I'm going to run it here directly on the URL that you see here. Let's see if we get an answer. The answer is hello from workers. That looks really nice. And now let's run that one, and it worked like a charm. And this is exactly the URL that my front end uses behind the scenes. So you saw it's really simple. I can focus on my Rust business logic. I can build a web API with a meaningful router where if I know a little bit about Rust, it isn't difficult to build something like that. And then with just a single line, I can deploy it. Limitations apply. I only have 45 minutes, so please read the documentation to learn more about this runtime environment of Cloudflare. There are others too, and they are also pretty awesome, but today I decided to go for Cloudflare. Cloudflare adds a lot of additional services like a key value store and many other things. You have a queuing system, and you can add a DNS front end in front of it. You can do a lot of stuff, and of course you can access all these things from inside your worker and your Rust code. So that was the first part. Well, strictly speaking, the second part of my demo, because we had the intro where you learned what's going on behind the scenes when you would like to run Rust code through WebAssembly in a JavaScript environment. Now, the second part was using exactly that technology to run it in a serverless way in the Cloudflare Edge Cloud, and now to something completely different. Because now I would like to talk about the Spin framework. Spin is from a company which is called Fermion, and Spin is essentially a framework which is not like Cloudflare running on top of V8, but it really uses WebAssembly Wasm components. So it's running WebAssembly natively. It's using a WebAssembly runtime like Wasm time to directly run WebAssembly without a JavaScript host below it. It's using a native WebAssembly host, as I said, like Wasm time, and they do not just offer this for running the code locally on your computer or locally in your Kubernetes cluster, but they also offer an edge cloud, and that's the interesting thing. I would like to demonstrate the differences between the approach of something like Cloudflare and something like Spin. Again, the important difference here is that we do not have a V8 below it. We do not use the V8 isolates in order to isolate the different environments. We still do not have containers. We still do not have virtual machines or something like this. We still work on WebAssembly, but now this thing runs WebAssembly directly on top of their infrastructure. I only have 45 minutes. I would love to tell you more about what's going on behind the scenes, but for now, that should be enough. You should now see or understand the different approaches that we have here. Now let's take a look at the code. Here is the code. And you see, of course, the business logic is the same. Again, a word puzzle generator, no question about that. But then, as you can see here, we have a method which is called handle word puzzle spin. As you can see it here. We don't need that one here. We can ignore that one here. This method is connected to our environment using another TOML file. This is the configuration file that is required for Spin. It essentially says I have one component It's in the Wasm file that is generated from my source code. Now I don't have Wasm pack and bindgen and so on because there is no JavaScript anymore. It's just Rust to Wasm. This is what we compile here, and this is what we get out. There is no JavaScript involved howsoever. And at the end of the day, this is now connecting everything together. It says whenever a request comes in, and this is the route, then please go into that WebAssembly, and here we have our word puzzle spin. Now if I take a look here we see the HTTP component, which is part of exactly that Wasm file. Now inside of our spin component, again, we have a router. Here, if you're not that familiar with Rust, this is a macro. We are using a macro to specify a GET request, a POST request, very similar to what you have seen in the Cloudflare world. Let me bring up the Cloudflare world and the Spin world side by side. Do you see here on the left-hand side, you have the HTTP router macro. You can also implement it without macros if you don't like macros, but I think you get the point. Here we have the GET request. Here we have the POST request. See it here? In this case, we have the generate puzzle handler function with a little bit different parameters. Like here on the left-hand side, we also have the generate puzzle handler function. The frameworks are different, but the concepts are naturally, because it's always HTTP, very, very similar. Now let's explore further what this Spin framework does. Essentially, very similar to what we had before. I'm deserializing the body. See, this is the body deserialization, so I'm getting the generator options. I'm validating the size. You see, I can return bad requests and things like that. I can call into my business logic, place words, and last but not least, I can JSON serialize the result and send everything back with a bunch of course headers to the client. So not really complicated. The question is, how can we now take this code and make it available in the Spin environment? In Cloudflare, this was really, really nice. It was just Wrangler, and it could dev, it could deploy, nothing special. Now with Spin, it is equally simple. What I can do is I can say spin build for building my code, translating Rust into WebAssembly, and then call spin up for running it locally, and spin deploy for deploying it into the cloud. Let's start with spin up, just as we did with Wrangler. Just spin, run it, and you see within a few moments I have my application running locally. So let's again go into the requests, and this time we use the port 3000, as you can see here, and hopefully it will answer, yes, this is exactly what I wanted to see. Hello from Spin. And if I run the generate here, we should see our nice little grid with all the words. So everything is fine. Spin is running locally, exactly what I wanted to have. Now that I've verified that everything works properly, I can deploy everything. And again, serverless means that I do not have to create and care for all the necessary underlying infrastructure. I don't run a Kubernetes cluster. I don't care for some kind of a registry like a Docker registry or Bindle or whatever. I simply take my code and say spin deploy. This is exactly what I want to do. So let's do that. Let's run just spin deploy, and this will now build everything, and it's deploying everything into the Spin cloud, into Fermion Spin cloud. They are responsible for running the serverless infrastructure and for deploying this across the globe. Again, I have to apologize that I don't have the time to tell you more about the possibilities, the limitations, and so on. Take this as your starting point for exploring the possibilities of these serverless infrastructures. You see, the application became ready within a few moments, and we got a URL here from Fermyon. Word puzzle spin something Fermyon app. Okay, let's try that. As you can see, I already added that here. I deployed that before, but this is now a brand new deployment. So there is no pre-baked stuff. We really start from scratch. And let's see if it answers in the Spin cloud. Let's run this guy. And hello from Spin. This is exactly what I wanted to have. And now run generate. And very nice. We again get the grid and get the words. Nice. And this, if we go back to the front end here, this is exactly what's going on here in the front end. If I take a look at this file, you will see that I'm just communicating with Cloudflare. This is the Cloudflare URL, and here I'm communicating with the Spin URL. So you have seen that alphabetic confetti works with Cloudflare. So now let's change this one up and let's here call Spin. And you see Spin also works pretty nice, and I immediately spotted banana here. And I see school here, and hey, feel free to do the puzzle and DevOps, and I'm pretty sure there are some diagonals and verticals. I think you got the idea how it simply worked. So we reached our goal. We have a serverless backend written in Rust, compiled to WebAssembly, but with two very much different approaches. On the one hand side, using V8 and the possibility for JavaScript to be the WebAssembly host, and on the other hand, we used Wasm components directly and used the Spin framework and the Spin cloud to run the Wasm file without any V8, without any JavaScript. Now you might, let's summarize, okay? Let's summarize. You might ask yourself, what about data? I mean, if you just have logic, that shouldn't be any problem. But what about data? If you run, for instance, your workers distributed across the globe, what happens if you have a central database? You don't win very much, right? Well, sometimes true, but in many cases that's really a problem. So when it comes to data, there are no simple answers. You have to think about how you distribute your data if you are able to distribute your data. Maybe you put your data in a backend as a service infrastructure. For instance, in Azure, they have a thing that is called Cosmos DB, which is able to distribute and replicate your data all across the globe. In Spin, they have the possibility to offer you a Redis-backed key value store. In Cloudflare, you have a key value store and many other options. But at the end of the day, things become way more complicated when you have to deal with data, and especially when you have to deal with transactions and things like that. This is in the nature of things. And Rust cannot change anything here. WebAssembly cannot change anything here. That's just Cloud Edge. That's just distributed applications. I'm happy that it's not too easy, because that guarantees that I will have a job tomorrow too. So yeah, I love these challenges. But yeah, this is a topic for another talk maybe. We don't need that one. So what? Let's summarize what I wanted to tell you, and then we maybe have a few moments for questions. My call to action for you is, if you liked what you have seen, learn Wasm and learn Rust. I always say, in the world of containers, your go-to language is Go. In the world of WebAssembly, your go-to language is Rust. So if you are fascinated with WebAssembly like I am, learn Rust. And if you want to use a platform like Cloudflare, which is based on V8, you probably have to learn a little bit of JavaScript and TypeScript if you don't already know these platforms. The second thing is make your users happy by being more productive. Many teams mistake being busy with being productive. Being busy building complex cloud infrastructures and CI/CD systems and things like that isn't being productive from a end user's point of view. By reducing complexity, by using tools like Wrangler and Spin and so on, we can simplify our process, bring the software nearer to our end customers, offer better performance, and that's the whole thing here. Again, reducing complexity. The frameworks that you have seen make it easier to distribute applications across the globe. Therefore, complexity is reduced. And finally, I'm not saying that using the edge cloud and using serverless is the solution to all problems. What I'm saying is that approaches like that can enhance your web solutions. Maybe you will still have full-blown web APIs in a central or 2 or 3 cloud data centers that are doing the heavy lifting. But think about what you can do if you can, for instance, put some aspects of your web applications, maybe things that you typically would do in a middleware, and you put it nearer to your end customer by using the possibilities that Edge Cloud and Serverless gives you. So see it as an additional tool, not as a replacement for large-scale cloud environments. And that's it. I would like to close with a citation of Jay Whittaker, a mountaineer, adventurer, and environmentalist. If you aren't living on the edge, you are taking up too much space. So try the edge cloud, and best try it with Rust and WebAssembly. Thank you so much for listening. Thank you so much for attending. I'm now open for questions.